Hello. In this video, we are going to demonstrate a chart showing the alpha values for various species of ethylene tetraacetic acid, EDTA. The structure of EDTA that predominates below a pH of 0 is shown on the screen. Notice that there are 4 carboxyl groups and 2 ammonium functionalities. So overall, there are 6 different acidic groups in this molecule. Here we list the pKa's for all 6 of the acidic functional groups in EDTA. Notice that the first 4 are between 0 and about 2.66, which is typical for carboxylates, and the final 2 are for the ammonium functionality. And here we have the chart demonstrating the particular alpha values for different species of EDTA at different pH values. Here is the relevant figure caption for the previous chart, or previous graph, if you want to call it that. Typically in a journal, these figure captions will be found immediately below the graph, below the figure. While we are demonstrating a physical science chart, I thought it would be a useful process to mention certain expectations that we have for charts, particularly in the physical sciences, in journal articles. So one of the first things is that in journal articles, physical scientists never use pie charts. So we'll notice in Excel it has a very large number of charts, many of which as physical scientists we would never use in journal articles. For charts in journals, we never provide chart titles. We put chart titles if we're making a presentation in front of a group of people, and we might have an overhead projector, for example. Then we would put chart titles on our charts. And we generally make students provide chart titles for when they graph the data in their experiments. But this is very unrealistic in journals. What we do instead are to provide figure captions, like the figure 1 we've seen so far, and these descriptions can often go on for many, many lines. So 2 lines would actually be a very short and rather brief figure label for a chart in a journal. On those occasions when we would actually use a chart title, we want to always have descriptive titles. So we don't want to have y versus x, where y is the quantity that's on the y-axis and x is the quantity on the x-axis. Even worse, students will often write x versus y, which is inversion of the proper order, since y is interpreted as being a function of x. So in general, when we even when we do have chart titles, we want them to be more descriptive than simply telling information that you could get from just reading the axis titles. So the axis titles don't just make up the entirety of the chart title. In charts for the physical sciences, we almost never use grid lines. On occasion, you will find scientists that will include grid lines in their chart, but overwhelmingly for the physical sciences, we don't do that. You'll see very often in fields like economics that they do use grid lines, which is perfectly fine, but we don't in the physical sciences. Typically, in things like XY scatter plots, we avoid grid lines. This is a problem because in Excel, the grid lines are a default. You have to specifically go in and check the box to get them to not appear. In many of the early versions of Excel, when you selected a chart, the chart background would automatically come up gray, which just makes your data very, very difficult to see. In newer versions of Excel, the background by default is white, which is what we generally want it to be. While I enjoy experimenting with all kinds of different fonts as much as anyone, in the physical sciences, we don't do that. Generally, there are only two fonts that we would use. One would be Times New Roman for text that involves Roman letters, and Symbol, which will give us the Greek letters that we need. So typically, those would be the only two fonts that we would use when we prepare a manuscript for consideration of publication in a journal for the physical sciences. Now for our seventh and final big no for physical science charts. I list this as no noisy data. And what I mean by this is that whenever we prepare these XY scatter plots, which are overwhelmingly the types of graphs that we make in the physical sciences, we always want to take a look at the final curve. So, for example, curves that are lines that are linear, ones that look like parabolas, are very easy to recognize. On the other hand, if our data seems to be jumping all over the place, that is also very, very easy to notice in a scatter chart. Typically, what we do in those cases is we put that type of data into a table. So, in general, if you see data entered into a table, one knows immediately that if you were to graph it in a chart, it would not give you a very nice looking figure. So, this is a hint behind the scenes for how scientists often choose between figures and charts. I thank you very much for your kind attention. Stay healthy, stay safe, and as always, have a good one.